Okay, welcome to lesson 1.8. 1.8 is not really anything new. It's just I just wanted to isolate it as a learning target because I do want to ask you to combine different things that you learned in this function in this unit. Really, just apply different knowledge that we've done, and to actually draw a function or a non-function. And so as a warm-up, we're going to look at two questions: draw a function with y is greater than 4, and then draw a function with f inverse of 2 equals 3. And so we want to talk about what each of those mean. And we will. So this is what we're going to discuss today, and see what these numbers actually mean. So greater than 4. Notice that for greater than 4, you can't just be at a point above 4 and then bigger than it. It has to be all numbers greater than 4, which include 4.0001. And so to do that, we actually need an asymptote. So we actually have to put a horizontal asymptote at 4, and then the function just gets bigger as we get bigger than 4. So this function has a domain that x can't be 0 as well, but you can see that it starts at 4 and it goes up, but it never actually hits 4, and that's what an asymptote does. The next one, what it means to draw a function with f inverse of 2 equals 3, it means that the input of the inverse would be 2 and the output would be 3. What that means is that the base function has the point 3.2. So the input of the base function would be 3 and the output would be 2. So we'll look at that. We'll look at one of those again in a second. So just bring us back to domain and range, asymptotes, and holes. So hole is actually a new thing today. But we're going to draw a function with x less than 4, y is greater than 3. And so that whenever you have less or greater but without the equal to, you can't actually have the graph at that point. So it can't exist at 3 and it can't exist at 4. But it needs to be everywhere less or greater. So you can't even just put a point above that. So two ways to do this. The first one is an asymptote. And so if you take a graph and we draw asymptotes at y equals 3 and x equals 4, then we can have a starting point about what we can reach. So now we know we got to be above 3 and less than 4, and so we have to have a graph that looks something like this. And so we approach those asymptote values, and that would have that domain in that range. The other way to do it is actually a hole. And so a hole is actually a new thing this year, and in the next unit we're actually going to see how algebraically we make holes. But what a hole is it's just a hole at a point. And so if we can't be 3 or x equals 3 and y can't be 4, if x can't be 4 and y can't be 3, but it has to be everywhere up to it, we just draw a little hole and then we draw a straight line where the function needs to be. Okay? And so a hole is actually kind of an interesting idea. So the idea can't equal, so we say domain x cannot equal 4, and we've seen that before, and that happens in the 1 over x graph. And so we just say if x can be everything but 4, we just draw an asymptote at 4. You can also do that with a hole. And so we put a little hole at 4, and then we say that we can be everything before and everything after. So that's also possible. X can be everything but 4. For coordinate points, so if you ever see something like this, remember from function notation, this means when the input's 2, the output's 3. And so when x equals 2, y equals 3, so you have a coordinate at 2, 3. But this is a little bit different. This is saying when x equals 1, the inverse is 4. And so that means that the inverse has a point 1, 4. But when x equals 4, the function is 1, and the function has the point 4, 1. And so we just switch the coordinates, and that's one of the points on the function. Draw a relation with all of, so this is an example that we could see, x is an element of the reals, range is greater than -3, 2, 4 is a point, and there's an x-intercept of 7, and then it's not a function. So we'll talk about how to make it not a function. So the first thing is we've got to be greater than -3, so we draw that line, that restriction line at -3, and so y has to be bigger than that. We can use that as an asymptote. We can also use it as a hole, but remember that we have to have x and element of the reals. So we have to have a point at 2, 4. So when the input's 2, the output has to be 4. It has to be a point at 7, 0. So the x-intercept is 7. And then we just draw a line. We make sure that we approach that asymptote so that we're everywhere bigger than -3. We make sure we go on forever in both directions and forever up as well. And you can draw virtually anything you want as long as it satisfies those things. However, this is a function. And if you needed to draw a function, this would be fine. But to make it a not function, you can virtually do anything you want, but one extra point on the graph, so just anywhere you want, will cause it to be a not a function, will cause it to fail the vertical line test. You can also do a loop-de-loop here, but if you add another point, it fails the vertical line test. Okay? And so that's some ideas that we want to look at in 1.8.